Hi everyone, my name is Vinay Vishwambaran and I'm a Principal Product Manager at Esri. And here I focus primarily on imagery, remote sensing, and geospatial AI. In ArcGIS, we've historically had a lot of machine learning tools to work with both vector and imagery data. And in today's GeoTech Spotlight, Hong will show you how she uses a relatively new machine learning tool within ArcGIS to predict above ground biomass. Hong, you want to introduce yourself quickly?
Thanks, Vinay. I'm Hong Xu, a principal product engineer specialized in imagery and remote sensing, with a particular focus on image science. Over the past 20 years, I've had the privilege of immersing myself in the fascinating world of remote sensing, and it continues to be my passion. So today, I'd like to discuss predict biomass. We use a multi-source of remote sensing data to create a biomass prediction using machine learning method. So let me show you a demo. Forest biomass is a crucial variable for assessing carbon storage and biodiversity. In this presentation, I'm going to demo how to create a biomass map for the state of Oregon to identify areas that need tree planting and potential fire zones. The workflow leverages data from multiple sensors. We'll use JEDA data as biomass training data, Landsat imagery, DEM, and the derived data as the explanatory variables. We'll then train a regression model to predict the biomass across the state of Oregon, and then perform subsequent analysis. The entire workflow is executed using a notebook on AMPC, which stands for ArcGIS for Microsoft Plenary Computer. Let's step through the workflow. First, we use trajectory dataset, which is a data model for working with trajectory data. We create a biomass trajectory dataset by ingesting JEDA L4A product and extracting biomass points from it. The output contains millions of points, which will be used as the training targets. Second, we create an image composite from the Landsat data in the cloud. We start by querying images in the study area for the year of 2022, create a RAS collection using Stack API from the query, then remove clouds and shadows, apply geometric media function to get the best pixel, and then create an image composite for the entire state of Oregon. These bands will be used as explanatory variables. We also calculate spectral indices that are related to biomass, such as NDVI, EVI, etc. Topological variability also influences forest growth. So we create a DM from the DM stack catalog and calculate the slope and aspect. The next step is to train a random tree regression model using the biomass data and all the variables we've just prepared. This resulted in a model with R-square of 90%, indicating very good performance. Using this model, we created this biomass prediction for the entire state of Oregon. From this biomass map, we can easily identify areas with lower biomass that require more tree planting. Additionally, we can calculate biomass per tree species to understand which type of trees contribute more to the overall biomass. Lastly, higher biomass is generally favorable, but higher dry biomass can increase the risk of fire. By combining this data with NDWI, we can identify areas with excessively dry biomass, which are potential high-risk fire zones. We can also use Pro to visualize the output. The red pixels indicate high-risk fire zones, which will help raise awareness and prompt government to take actions in these identified areas.